After that we will discuss some basic different types of wireless signal. WAN, LAN, PAN we are saying. WWAN means we are connecting through WAN connectivity. So generally what scenario we will have the tower. From tower we can get the RF signal or Wi-Fi signal. We can connect our internet, we can access, or we have the satellite, we have the dish. So different option we have to connect that one. Generally WAN, that is a wireless local area network. It is nothing but we are using the access point or the router, Wi-Fi router. So this is a basic scenario. If we see here, we have the Wi-Fi, that is a router. This is a router. It is not having the wireless. It is having only router functionality. ISP cable is connected here. From here it is connected all cable. But in this area we need the wireless signal. So what we done, we connected one access point. So access point is taking the wired signal and it is converting into wireless signal. And in this area you will have the wireless coverage. So after that we have the PAN. Nowadays no one is using, maybe some scenario you will see this one. PAN is nothing but connecting with the Bluetooth. You will connect the devices with the Bluetooth. Before we are using this lot, but nowadays not that much, maybe only for headphone and sometime laptop, and especially for the printer and mouse we are using, but not more we are using this. Nowadays we have the USB or maybe headphone also connecting with the Bluetooth. So but this is also one of the way before we are using, but we have the limitation here, within 10 meter we need to use, after that we cannot connect. So this is a PAN. Then we have the devices. So wireless device, this is a set of device. Example, if you want to run the wireless in your office or home, what we need in the scenario, even if you have a small scenario like maybe you have 3-4 access point, you can use the controller. So this is a basic setup. You will have one controller, WLAN controller, then you will have the access point, and then from there you will have the wireless devices. Maybe you will have laptop or mobile phone, iPad, iPhone. So this is a basic scenario for the wireless setup. So in the wireless devices we will have the NIC card, that is network interface card, and we will have the access point. All the laptop, everywhere we have the wireless chip, even in our mobile phones. So our hardware is the Wi-Fi hardware which is connecting to our signal. And then we are saying the WAP, that is wireless access point. Just now what we discussed, same thing. We have different scenario, different access point we have. Main function is it is used to convert the wired signal into wireless. Mostly we are finding, before in the olden days we are finding this in the home or small office, airport, coffee shop only. But nowadays in the big organization also access point and the wireless signals are used. Wireless is used everywhere. Everywhere wireless is used. So this setup and ad hoc network we have, this one no, now we are not using. What is the main purpose means, here before when we don't have any infrastructure, if we want to connect the PC, we will connect directly PC to PC. But nowadays we are not using this one. Example, if this guy want to send any signal to this guy, imagine this PC want to send anything here. So this will first go to this PC, after that it will come to this PC. So this is not secure way, because whatever this PC is sending, this PC know already that one, and he is forwarding. So this is not a secure way. We are not using any more this. In the olden days we are using this. Now we have the infrastructure mode. In that mode we will have the devices, like you will take the internet connection, you will connect to the router like this. Here you will have the internet connection, that cable will go to router. From router you have the NAT pad here, you will, and DHCP server also, and from there you will get the IP, you will connect to the switch. From switch you will connect to the access point. Access point will convert into wireless signal and it will go give to all the devices. And if you want to connect the server and the workstation, we can connect. So this one we can call this as the infrastructure of our organization or infrastructure model. This is a small organization, just we have only one switch. But if you go for the big organization, you will have lot of switch, maybe 200 switch, depend company to company. So this one is just, we need to have the idea. This is basic setup. Whenever you want to set up, you will have the internet connection, router, switch, and the access point. This one we are calling infrastructure model. And here what we are doing, if you see here, we deploy one access point, but some scenario we don't have the coverage. So what we will do, we will use one more access point and we will deploy. We will use switch and we will connect more access point. Example, in some area, example in this area, if someone is complaining they don't have the coverage in this area, then we will take one more run, we will run the new cable from that switch and we will install the access point here. Generally we are doing like we are installing the access point also. So now some terminology we can see wireless, like what is SSID, what is BSS. Just we need to have the idea. SSID is nothing but service set identifier. If you see in simple, that is a Wi-Fi name. Example, if I want to check, this is a Wi-Fi name. So this one is known as SSID. We need to remember, sometime in interview they are asking. So you need to remember the full form. Service set identifier. SSID is a name of the Wi-Fi network. Unique ID used for naming the wireless network. So client device can join the wireless network depending upon that name. A single access point can have the multiple SSID. We can have the multiple SSID. If you see here also, I think before here, if we go to the GUI here, you have the 3 here. If you see, we have the 3 here. So this is having the, let me check here, yeah, this one. You are having SSID is default. You can change. Example, you can write here A, B, C, here X, Y, Z, and here we can say anything A. So here one access point, we have one access point, but we are keeping 3 different names. So this is also supported, depend model to model. So that's one I am saying here. A single access point can support multiple SSID. So we can keep the different SSID. And we can define different VLAN also. For this VLAN we should use this SSID. We can create depending upon our requirement. And if you see here, this is the area. We have access point here, and this is my SSID, my network, I give the name, and this is the signal are connected to our devices. And whenever we are using the access point, we need to remember our PC to PC communication will not direct. It need to go to access point, then access point is going to forward the traffic. We will not go directly. We are using infrastructure, so this need to go to access point, again access point. Even if you are near, you are sitting beside this, but they cannot communicate directly. This need to go to access point. From access point only they will communicate, not direct. Okay, and this one, what we can say, this is the area. In that area we are getting the coverage. So BSS, we are calling this as a BSS. If you see, basic service set. BSS is nothing but basic service set, and BSSID. So this is a MAC of the access point. So what is basic service set? Basic service set is nothing but it is a area. If you see here, where we have all the client and everything. With the basic service set, wireless client connect to the wireless network through a AP. The idea behind BSS is the AP is responsible for the wireless network. The BSS used for most wireless network. Each wireless client, if you see here, this one we can say BSS also. Access point is connecting here. So in simple, what we are saying, BSS is nothing but it is a basic service set. In that one you will have the access point. Access point is going to connect to the client. So this complete set we are calling as a basic service set. Okay, and then if you see BSA is nothing but area, service area, basic service area. So example, if you have one router here, you have one switch, this is the access point. This access point is covering this much area. Whatever area they are covering, that is known as basic service area. BSS stands for basic service area. BSS is a wireless coverage area of access point and also known as wireless cell. So just we need to remember, what we need to remember, BSS is nothing but area. How much area this access point is covering is known as basic service area. Whereas BSS is nothing but it is a set. We have the access point and client. That set is known as basic service set. And basic service area means how much area we have the coverage. Then we have the distribution system. And the distribution system is nothing but you have the access point and you have the client. If the access point, example, if this guy want to access the facebook.com, in this scenario, imagine in this scenario here, or maybe in this scenario, this guy can communicate with this guy only, and this guy can communicate with this guy only. If they want to go outside the network, they cannot. If they want to go outside the network, then we use this what we can say, distribution system. In that one, what we have the access point, we have the client, and then we have the switch, and we will connect this to our gateway and then internet, so they can go to the outside. So this complete one we are calling, this is a complete system. But if you see here, the connecting this switch to the WAN, that is gateway to our access point, that is known as distribution system. So when we put the distribution system, these guys can go outside the network. So this is like this, we can create 3 SSID to one access point, and they can go to outside the network. And we can create the different VLAN, we can put in different VLAN, depend where we need to keep. And then we have extended service set. This is the same thing like basic what we can say, distribution area, like this only, distribution system. But here we extend. Example, if we don't have coverage in more area, so what we will do, we will extend the service set. What I done, in this area we are getting the coverage, in this area we are not getting the coverage, so we will install one more access point, and both are in the VLAN 10 and it is connected to ISP or internet. So easily this guy can go here or go here, he can connect to the area. Okay, then we will go for RF overview. So here we are saying RF signal, we are saying Wi-Fi signal, RF signal, radio frequency signal. We are sending the signal in the form of radio frequency. So if you see, generally what we are doing, we are sending our signal before we are sending the signal in the cable. Okay, to send the data across the wire link, an electrical signal is applied at one end and carry out the other end. Generally when we are using the Ethernet cable or any cable to send the signal, we are using some electrical signal going through the cable, that is a wire, and wire is a good conductor of electricity and he is going to carry the signal, as we know. But now in the wireless we have the open space, we don't have any what we can say, we don't have any medium to send the electricity or any signal. It is a open space, it is a open place, we are sending in the air. So when we are sending in the air, we need to have the signal in the vibration form, then only he can travel long distance. If you see this example, they are saying sender and receiver. This guy is going to send the traffic, this guy is going to receive the traffic. Sender is nothing but who is going to transmit the signal, that guy is known as sender. And whoever is going to receive the signal, that guy is known as the receiver. So what we have, this guy is going to send the signal. So what they done, this guy just moved the rope. They are taking one rope, they are standing in a long distance, and the sender just moved the rope up. When he moved the rope up, we have some vibration in the rope, but after some time it stopped. And the other guy, whoever is receiver, he did not notice that this guy moved up. So this example we are using, like example, if I want to send some signal from here to here, the signal should be in the vibration form, then only it will reach. If it is not in the vibration form, it will not reach, because this guy moved the rope up. We have the tiny voltage here, we have some difference here, tiny distance. After that it will drop here only, that vibration. It not reached to the guy, and this guy did not notice. But if you see another example, the sender is moving his hand up and down. He's having the rope in his hand and he's moving up and down, up and down, up and down, like this. So this signal is going up and down, and it reached to the receiver, and receiver noticed there is some signal here. So with that one, we are saying whenever we want to send the signal in the air, in the media, that is air, we need to send in the vibration form. If you see here, when we are sending the signal, we are sending as in the magnetic and the electric field. So both are sending in the signal, and it is traveling as a sinusoidal wave in the media. If you see, if you have water in a lake, if we drop any stone there, how waves are rippling, like same like that our signal is going to transmit. Like when we are using omnidirectional antenna, he is going to transmit like this way. So they give the example like whenever we are transmitting the electromagnetic signal in the free space, it will expand in this same fashion. Okay, and already we discussed the guy who is sending the signal, it is known as sender, and the guy who is going to receive the signal is known as the receiver. So this guy is sending the signal, he is sending the electromagnetic signal. Okay, and that is electromagnetic signal, that is RF signal. So it is going in all the direction, it is in omnidirectional. And this guy is going to receive, he is a receiver and he is going to receive that signal. So the guy who is sending, he is known as sender, and the guy who is receiving is known as receiver. And after that we should know the frequency. Frequency is nothing but rate at which signal vibrate. Rate at which signal is vibrate. If the signal is vibrating slowly, then we can say low frequency. If the signal is vibrating fast, we can say high frequency. And frequency is measured in the hertz. And we have the frequency as a licensed and unlicensed, both we have. High frequency, low frequency, we have all different frequency. We have licensed and unlicensed, but for the wireless technology we use the unlicensed. Unlicensed means no need to register with the government anything, we can use it, is used in our organization, in your organization, same frequency, no issue, because wireless signal are unlicensed. And if you see, this is our low frequency signal and this is our high frequency signal. This is a amplitude in the y-axis, time in the x-axis. And when we see this is a low frequency, we can say this is a high frequency. And if you want to check, we can check with this website also. There is one website, we can check here also. If we go here to this website, we can check the signal also here, just to have the idea about the how signals are traveling in the form of wave. It is taking some time, but anyhow, let's look some theory, then we will come back to this side. It is open or still taking time, so let it be load. So now we will see radio frequency. All wireless devices operate in the radio waves range of the electromagnetic spectrum. So our LAN, that is our wireless LAN network, operate in the radio wave, and we are using the frequency of 2 band, that is 2.4 gigahertz frequency band we are using, and also we are using 5 gigahertz frequency band. This 2 band we are using for our radio, our Wi-Fi signal. And if you see here, we have lot of signal. The electromagnetic spectrum is having radio wave, microwave wave, infrared, visible rays, X-rays, gamma rays. But now we need to just remember we are using this 2 band for our Wi-Fi signal, 2.4 gigahertz frequency band and 5 gigahertz frequency band. And let's see, this side came up, or yeah. So if you see, this is a wave. This signal is going in the form of wave, sinusoidal wave. And here, if you want to check, this is a vertical. If you want to check the horizon, this is a horizontal. And if you want to check vertical, it is going vertical. And this is the amplitude. If I reduce the amplitude, it is a straight line. If I increase the amplitude, it is going high frequency. And this is a wavelength. We can increase or decrease the wavelength, just to have the idea about the wave, how wave is going. So our signal is going in this form, in the wireless, and we are calling this is a signal. It is going in 1 cycle, that is frequency is equal to 4 cycle per second. So just we need to remember, this is a formula. Frequency is nothing but 4 cycle per second, or 4 hertz. So what is cycle we are calling? This is a cycle starting from here and ending to the same point, that is known as 1 cycle. And after that, what we can say, we are having the hertz. Hertz is nothing but unit to measure the frequency. and amplitude is nothing but height. If you see, this is a height, so this height is known as amplitude, the height from the top peak to the bottom peak signal wave. And wavelength is nothing but the difference between the crest and, example, this one starting signal from here on the peak, and again we have one more peak, so this distance is known as wavelength. This just term we need to remember. And this is a frequency units. Frequency is measured in the hertz, kilohertz, megahertz and gigahertz. And this is frequency band, but the one which we are using for our signal is 5 gigahertz for wireless and 2.4 gigahertz for wireless. So this we need to remember. Sometime in interview they are asking. So 2.4 gigahertz and 5 gigahertz we use for wireless signal. And this is just a design just now which we take. This is a home router. Already we take here, just I put the scenario same like this. So we can take that one and we can change the SSID, we can connect the devices, and we can make the communication automatically. They are going to get the IP and we can ping. Example, if you see here, maybe this machine, if I go here, if I select as a DSCP, we are going to get the IP from the DSCP. Let's see what IP I will get here. I get DSCP fail here, so maybe some issue with this router. Maybe we need to restart or something. Maybe DSCP is not working there. So generally we will get from the DSCP. Yeah, DSCP IP not receive here, so maybe some issue here. Yeah, because I change here. Okay, I put ABC here, right? But here in this PC we have the default. So let me go here, and here I will change as a this one. Where is password? Let me take this device here, desktop configuration, this wireless 0. I will write here ABC. Now we have the same authentication. ABC I use right here. Let me check what I wrote here. Default. Here we have default. Just now I put somewhere ABC. Where I put ABC? Do we have 2 access point or only 1 access point? So this is only 1 access point, so we should get here. Why we are not getting? Let me do fast forward and let me check what IP we get here. Yeah, here we are getting correct. Okay, so maybe because of STP it is not getting correct before, but now I think we get correct IP. If I go here and again check here, which PC, this PC, maybe we have some issue with this PC, because the cable where we connect this cable maybe not particular that port. If you see here, we need to connect this LAN port 1 2 3. I don't know where I connect this cable. Let me remove this cable and let me check where it is having the option. Okay, we will connect to this one, not the internet. Now we will get the IP. Now let's go here and check. Now I get the correct. Okay, so be careful when you are connecting this cable. We have this port, this is for internet. ISP cable will connect here. The other cable in your LAN network you can connect here, anywhere here. So I connected here, so now our machine get the correct IP. 108 I get here. Example, I want to ping from another machine, I can do. Let me get the IP from the DSCP, and this PC is 108, this is 109. So I can go here in the CLI and I can ping here. Let me write here ping 192.168.0.108 or 109. 108, this is what 108. Yeah, so I can ping from 109 to 108. So this way we can access. Okay, so make sure this cable connect to our port, not the internet port. And same like that you can communicate with the wireless device also. And if you go in the wireless, you get the IP 105 here, so you can ping. Okay, so let's see here. This one just I am showing you this only. And if you want to change the password, we can change password also. And after that we have the wireless architecture. Architecture means how we can connect the devices in our organization. So we have first one is a autonomous architecture. In the autonomous means same architecture, we have the core layer, distribution layer, access layer, but here we have the access point. at last, but this is a autonomous access point. So when we are having the autonomous access point, that is known as autonomous AP architecture. And this access point is intelligent and we need to configure individually because it is not controlled by the wireless LAN controller. And the other one is a cloud based architecture. So in this one we will have the controller in the cloud, that is Cisco Meraki cloud. We need to take the access from the Cisco, that is they will give you the login detail, you can log in and configure through internet. So this controller will be in the cloud with the Cisco, and just you have the login detail, you can log in and push the configuration whatever you want to push. So here you will have the Cisco Meraki controller and you will have the Cisco Meraki access point, and this is the access point which is going to control by the wireless LAN controller, and they are using CAP web protocol to communicate the access point to the controller. Okay, and then we have centralized wireless network, same like this only, but here we have the controller in the cloud, but here we will have the controller in our organization. And here we are using the lightweight access point, and we are using CAP web protocol. CAP web protocol we are using, that is a CAP web tunnel. It will make the tunnel between the WLC controller and the access point to communicate. They can communicate, they can fetch the configuration from the controller and they can start working. Then we have the split MAC architecture also. In that one, access point is also having the control. In the before, access point like a dummy, they are getting everything from the controller, but here they can manage themselves. First time they will get the what we can say the configuration from the controller. After that they can manage the traffic in the split MAC. After that we have the converged wireless network architecture. This is the same like that, but here what we will have, controller is going to install in the access layer switch. So controller is near to the access point. In some organization they will install the controller near to the access switch. So controller will be connected to access switch, and after that lightweight access point is connected. So this types of architecture is known as converged wireless network architecture. Configuration everything will be same, only they have the controller instead of here in the core layer, they will come to the access layer here. And then we will go for the roaming. So generally what is roaming? Roaming is nothing but moving. That is wireless roaming is when a wireless client or station move around in an area with a multiple access point. It may automatically switch to another AP depending upon the best performance or the signal strength. Example, this is our switch and I connected one access point here and another access point here, and this guy is moving from this area to this area. Automatically this guy device, that is a client, is going to connect to other access point. They are going to check which access point having the high signal, he is going to connect to that one. So whenever this guy is in this area, this access point is connected. When this guy go to other area, this access point is connected. That one is nothing but roaming. We can say wireless roaming. Automatically it is going to connect. So what we can say, it is like a, we will have this client, that is a host or the mobile MAC address, everything here, and they are checking this guy is moving where, and wherever he is going, automatically it is switch from one device to another device. Okay, example, here we have two access point here. One client is here and another client is here, and this is a scenario. They will have the AP association, if you see here, and they will have one entry in this AP, but when this device is moving to the other area, automatically this entry will go to the other AP. If you see this way, when this device move from here to here, entry will be enter here, and this is in the same VLAN. They have the same SSID, they have the IP also same thing, just they are moving from here to here. So access point is going to take the record. If this client is here, they will enter in his association table, and if it is moving to other, it will remove from his table and it will move to other table. And after that, if like this guy is moving, so all the access point is going to cover him. So this is no problem, but the problem when you have the controller, example, intra controller roaming. Intra means same area, Inter means different controller. So now when you are moving, you have the controller, like you are using the one controller. If you see, this is a wireless LAN controller, and wireless LAN controller is communicating with the AP, that is CAPWAP protocol. CAPWAP is nothing but control provisioning of wireless access point. This is a protocol they are using. They are making the tunnel so access point can communicate with the controller. So whenever wireless LAN controller is here in this scenario, we are using the wireless LAN controller. We are calling the intra roaming, means same wireless LAN controller. If we are using same wireless LAN controller for all the access point, then we are calling intra controller roaming. Before we don't have controller here, just as a standalone AP. Now we have the controller. So now we have only one controller, both are connected to the same access point. So they are going to store the information in the association table. If this guy go here, they will move entry from here to here, like this. But after that, it is no issue. They can go, they can move, this is okay, everything will be okay. But the problem, when we will have the problem, like when we have the controller in the different VLAN, or we have the different controller. Example, you have here WLC controller 1, WLC controller 2. So we have two controller here. Before we have only one controller here. If you see, only one controller, this guy can move here easily. But now we have the roaming between centralized controller. So as a wireless network grow, one controller may not be sufficient. So what we will do, two or more controllers support the AP in the enterprise network. Okay, so now we have the layer 2 roaming. So in that one, we have the two different controller, and they are connected with the switch. So this is also okay. They have the some millisecond delay here, and they will reconnect the client. If you see here, I wrote here, when a client roam from the one AP to another AP, lie on the two different controller, the client make a inter control roaming. Inter means two different controller. WLC controller 1 associate in his database, that is a client 1 on the AP1, this table. When the client decide to roam and reassociate itself with the AP2, actually move from one controller to another controller, the two controller must coordinate. They are going to coordinate, and they are going to make the entry of this client from this table to this table. Before the roaming, the client 1 is associated to AP1 with the IP address and VLAN and subnet mask. And after they both controller associated, they will give the same VLAN and same IP. So if this guy is here, they will get to other entry also, they will get same information. So this both controller is going to coordinate, and then they will give that information. That is known as layer 2 roaming. And then we have the layer 3 roaming also. Here you have usually less than 20 milliseconds. So in millisecond you will have this. And then you have the layer 3 roaming. What if the wireless network grow even more, such like WLAN interface on each controller are assigned to different VLAN and different subnet. So like this, here we have the different VLAN. Here we have the same VLAN. But now our network is growing more and more. That one is known as layer 3 roaming. So when our network grow and we have different VLAN, we have more access point, we have more controller, then what we will do in that scenario also, we have the DSCP, we need to get the IP, different IP, we are going to get different IP here and here. Example, here we have the client and connected with 100.199. Now he is going to move from here, and he's going to get to other one. In that scenario also, they are using the CAPWAP tunneling protocol in between the switch, because they are both are different controller. Example, if I am connected to the WLC controller 1, I am calling that one as an anchor controller, and the other controller I am calling as a origin controller. So I am here, and when I am moving here, this both controller is going to communicate by using the CAPWAP tunneling protocol, and they are going to exchange the information, and same detail whatever this controller is giving, that same information is going to assign to this controller, this host. So if you see here, before I am getting the IP here, what IP? 192.168.100.199. same thing I am getting here, 100.199, this one. So this controller need to discuss and they are going to exchange the information. At last we will have the same IP, and we will not see any delay also. They will do in very fast, in milliseconds. So just we need to remember, in the layer 2 roaming means we have the controller that is in the same VLAN, same subnet. Layer 3 means different VLAN, different subnet, and they are going to communicate with the what we can say cap web tunneling. And then we have locating device in a wireless network. So we can locate the device where this device is in the network. Like wireless network are usually designed to provide the coverage connectivity in the all area where the client device are expected to be located. And we can have the coverage. Generally we are giving the coverage wherever we want to, wherever we have the client. But we have one feature also, we can locate the location of the client also, where this client is present currently. Generally we are using this in the shopping mall, also in the hospital. Many places they are giving you the free Wi-Fi, but they are tracking you where you are going. If you are going in the mall, which store you are going inside the mall, so they can advertise online. They can track your interest depending upon your location. So there is a feature also like location detector. They can detect also where you are going. So how they can detect? They can check the which access point you are connected and how much signal strength you are receiving from them. Depending upon that one also they can track you. Like example, you are here, you are connected to this access point and you are getting how much signal strength, so you are away from this many meter. Like that we can track. And we have one more different thing also in the real scenario we can track, that is RTL. How we can track means we need to have some devices like Cisco Prime infrastructure or DNA center along with the location server like Cisco Mobility Service Engine, MSC. We have this engine, so we can connect. Example, you will have the Cisco Mobility Service Engine here, and there is a third-party locator application. They have the maps, all that one in that one, and this is our controller, and we have the wireless access point on our devices. Wherever it is going, that all information will go to our mobility service engine, so they can locate location. Depend company to company where they want to use, especially in the hospitals and also in the big shopping mall, shopping area. They are using this one to locate where is user with the wireless signal, so they can locate easily. Like in the museum also they are using where this guy is going. In the health care center also they are using this technology. Okay, so what we need to remember, how we can do that one. We need to have the Cisco AP WLC controller integrated with the management platform like Cisco Prime or DNA Center, along with the location service like Cisco Mobility Service Engine. This is a setup. So with this one they can track our location also, where we are going and like all that one. Okay, so after that let me stop this.